In this video, I will introduce the basic concepts of statistical adjustment. Statistical adjustment is a very common practice employed in epidemiological research, often with the purpose of reducing confounding bias. The main requirement of statistical adjustment is that we have measured the potentially confounding variables of concern. If we did not measure one or more of the potentially confounding variables, then statistical adjustment is no use to us. First, I will demonstrate the stratification method of statistical adjustment. Here's a 2x2 table for outcome by exposure status from a cohort study. Based on our data, we find that the exposure is associated with a 50% greater likelihood of developing the outcome. So now we have evidence that our exposure is associated with our outcome. But then we take a look at our data and we notice that those in the exposure group tend to be older than those in the unexposed group. Not only that, but we know that older people tend to be more likely to develop our outcome of interest. And so we're worried that we found an association between exposure status and our outcome simply because those who were exposed tended to be older than those who were not exposed. In other words, we are worried that it's age that causes the outcome and not our exposure of interest. In this case, age is the confounding variable. We want to know if we hold age constant between the exposed and unexposed groups, do we still see an association between our exposure and our outcome? One thing we can do is stratify or separate our sample by age, then look at the association between exposure and outcome in both younger and older adults separately. In our example, after we split our sample into older and younger adults, our relative risk in younger participants is 1.29, and our relative risk in older participants is 1.33. Remember that our relative risk before stratification was 1.5. After separating by age, each relative risk is less than 1.5. This means that a portion of the association we found between our exposure and our outcome was due to the fact that those in our exposed group were older than those in our unexposed group. Because when we take age out of the equation by stratifying, or in other words, when we hold age constant, we see a decrease in the relative risk. In order to get an estimate of our adjusted relative risk, in other words, after adjusting for age, we can calculate the average of our stratified relative risks. We weight this average based on the sample size for each of the stratified groups. One example of doing so is called the Mantel-Hansel method. In our example, before accounting for age, our relative risk was 1.5, and after adjusting for age using the Mantel-Hansel method, the relative risk was 1.31. In other words, if our groups had equal age distributions, the exposed would be 30% more likely to develop the outcome than the unexposed. The most common method of adjusting for potentially confounding variables is called multiple regression. I will not go into details about multiple regression here, but the goal is the same thing. We're studying the association between two variables, and we want to hold constant any potentially confounding variables.